Topic: Fermi level shift in N-type semiconductor. Show a glowing silicon crystal right pointing arrow, then zoom into energy band diagram. Hello everyone. In this video, we are going to understand one of the most important semiconductor concepts, the Fermi level shift in an N-type semiconductor. We will learn what the Fermi level means, what happens during doping, and why the Fermi level moves upward toward the conduction band. Basic concept: energy bands in semiconductors show conduction band, EC, valence band, EV, and band gap, EG. First, let's recall the energy band diagram of a semiconductor. There are two main energy bands: valence band, EV, where electrons are normally present and bound; conduction band, EC, where electrons are free to move and conduct electricity. Between these two bands, there is a forbidden region called the band gap, EG. Electrons cannot exist inside this gap. Now, the position of the Fermi level inside the band gap is very important because it tells us about the electrical behavior of the material. What is Fermi level? Show Fermi level EF in the middle of band gap. The Fermi level is defined as the energy level at which the probability of finding an electron is 50% at thermal equilibrium. In a pure semiconductor, which is called an intrinsic semiconductor, the number of electrons is equal to the number of holes. So, the Fermi level lies approximately in the middle of the band gap. What is N-type semiconductor? Doping concept. Show silicon lattice. Add a phosphorus atom, donor impurity. Now let's convert intrinsic silicon into N-type silicon. For that, we add a pentavalent impurity such as phosphorus, arsenic, antimony. These atoms have 5 valence electrons. When a pentavalent atom replaces a silicon atom in the lattice, 4 electrons form covalent bonds with neighboring silicon atoms. The 5th electron becomes loosely bound and is almost free. This extra electron easily enters the conduction band and increases the number of free electrons. So, in N-type semiconductor, electrons are majority carriers, holes are minority carriers. Donor energy level formation. Show donor level, ED, just below conduction band. When we add donor atoms, a new energy level is created inside the band gap. This is called the donor energy level, ED. This donor level is located very close to the conduction band. Because it is close, only a small amount of thermal energy is needed to move electrons from the donor level into the conduction band. That is why even at room temperature, N-type semiconductors have a high number of free electrons. Main concept: why Fermi level shifts upward. Show intrinsic EF in middle right pointing arrow, then gradually move EF upward toward EC. Now comes the main question: why does the Fermi level shift upward in N-type semiconductor? To understand this, remember, the Fermi level represents the energy level where the probability of electron occupancy is 50%. In intrinsic semiconductor, electrons equals holes, so EF stays near the middle. But in N-type semiconductor, donor atoms add a large number of electrons, so electron concentration becomes much higher than hole concentration. Since electrons are now the majority carriers, the energy distribution changes. So, the Fermi level shifts toward the conduction band because the conduction band is now more likely to be occupied by electrons. Therefore, pushpin in N-type semiconductor. EF moves upward closer to EC. Effect of doping concentration, important point. Show light doping right pointing arrow EF slightly up. Then heavy doping right pointing arrow EF very close to EC. Another very important point is, the amount of shift depends on the doping concentration. If doping is low, EF shifts slightly upward. If doping is high, EF moves very close to the conduction band. So, we can say, push pin higher the donor concentration right pointing arrow closer EF to EC right pointing arrow higher conductivity. In very heavily doped N-type semiconductor, the Fermi level can even enter the conduction band. Such semiconductors are called degenerate semiconductors. Final summary, perfect ending. Summary slide with icons and final band diagram. Let's summarize. Intrinsic semiconductor. EF is in the middle of the band gap. N-type semiconductor. Donor impurities increase free electrons. Donor level forms near conduction band. Electron concentration increases greatly. Fermi level shifts upward toward the conduction band. More doping means EF moves even closer to EC. That is the complete explanation of Fermi level shift in N-type semiconductors. Thank you.